Hello all and good day. My name is Jason Opdycke and I am the Chief Technology Officer for Microsoft's DoD software business. On behalf of the collective Microsoft DoD team, I'd like to thank you for tuning in and watching this quick video demonstration and discussion around the Internet of Things. With the Internet of Things, the possibilities are endless, and we hope this simple demonstration piques your interest in Microsoft's IoT capabilities with Microsoft Azure and Power BI. When I think about IoT, and really business intelligence for that matter, it comes down to one common problem statement, question, and goal. And that is, how can my organization gain insight from all available data to drive a competitive advantage? That's static data, real-time flowing data, reference data. And how can I ensure that I'm processing and analyzing the data with enough speed and impact to really gain competitive edge? How can I reduce the noise, or fog of war if you will, and bubble things up that really matter to my operators and decision makers? By 2020, an estimated 30 to 50 billion devices will be connected to the Internet. Each of these devices will have the ability to collect and communicate massive amounts of data. And as these devices become more sophisticated, they are incorporating the ability to analyze data, plan, manage, and make intelligent decisions autonomously. The Department of Defense, to some extent, has been on the forefront of this revolution. Planes, ground vehicles, ships, spacecraft, and weapon systems have been networking and sharing tactical data long before IoT gained momentum in the commercial world. And the defense industry has pioneered in the development of machine-to-machine communications and unattended sensors. If we think back over time, technology advances thus far have come in a couple of key echelons. The Industrial Revolution enabled countries to outmanufacture adversaries through faster production of trucks, tanks, ships, bombs, planes, bullets. Precision-guided munitions and highly technical weapons systems enabled a new revolutionary change to how defense tactics played out. But what's next? In today's age of cyber, software, limitless data, perhaps the next revolution in the defense sector is predictive analytics and machine learning, enabling our operators and decision makers to have better intel faster than ever before. With the growth of autonomy in vehicles, sensors, and networks, the connected battle space of the future, one in which every asset, human or machine, can communicate and share data, seems within reach. Okay, let's dive right in and start by walking through the architecture of today's demo. For an IoT solution built on Azure, think of Azure and its associated platform capabilities as a toolbox full of tools. We'll talk about each of the components and which cloud services in Azure we are showcasing today. But we'll also talk about some of the other cloud services in the Azure toolbox available to you, depending upon the needs of your application. Don't worry, I'm going to show all of this working and the configuration behind it. But first we need to start with a lay of the land. We start off today with an IoT sensor that's producing events. My particular sensor connects to a PC via Bluetooth, but you can imagine how many different sensors, operating systems, connectivity options there are available on the market today. Or maybe your organization manufactures devices with capabilities like this built in. In our case today, we've got a .NET Windows application that is listening via Bluetooth to the sensor and sending the message details to Azure Event Hubs. Azure Event Hubs is an Azure platform service that's a highly scalable publish-subscribe event ingester that can intake millions of events per second so that you can process and analyze massive amounts of data produced by your organization's connected devices and applications. Additionally, we're seeing a lot of our customers appreciate the cross-platform support and ability to bridge disparate devices and data in Event Hubs. These customers have a combination of devices using differing OSs and connectivity models. Event Hubs support for HTTP, advanced message queuing protocol, and available native client libraries allow many platforms to plug right into Azure Event Hubs, resulting in less development and customization efforts for our customers. In today's demo, an Azure Event Hub is intaking the messages, and then we are transforming, processing, analyzing these messages in near real time with Azure Stream Analytics. Because this is a managed platform service in Azure, development time is cut dramatically, and you will see that we use simple SQL-like syntax to reduce the noise and process these live messages before outputting our filtered and transformed data into our presentation layer of Power BI. Power BI is Microsoft's hosted cloud business intelligence solution that enables your users to transform your company's data into rich visuals, to spot trends, and to find opportunities at a glance. Power BI allows for an easy-to-use self-service style of analytics. I'm going to show you today how easy it is to visually explore your data in Power BI's free-form drag-and-drop canvas. Now, there are many other tools in the Azure toolbox that could have been used. We could have passed the data ingested by Event Hubs into a machine learning or Hadoop HD Insight. We could then store the processed outputs in SQL, table storage, blob storage. We could even use any presentation layer solution available, custom web applications, API applications, or Azure's alert and notification hubs. This is the IoT sensor that I'm using today. It's a Texas Instruments sensor tag CC2541. It cost me roughly $30. It actually has about 10 sensors on it, including pressure, accelerometer, gyroscope, magnetometer, and as you'll see today, we're only using the temperature and humidity sensors in today's demo. I chose this sensor because of its simplicity and out-of-the-box functionality. Any sensor is able to be used as long as the data can be sent to Azure Event Hubs. If you're a Raspberry Pi, Arduino, or NetDuino expert, feel free to use one of those. Heck, Windows 10 IoT Core version even runs on the Raspberry Pi now. Now let's jump to the actual demo, and we'll start on a Windows PC that the IoT device is connected to and that our .NET Windows application is running on. This happens to be a Windows 10 machine, but I've also tested this demo on Windows 8 and Windows 8.1. You can see here in PC settings that we have paired and connected our Texas Instruments sensor tag to the PC. We also have our .NET Windows application currently running and receiving data from Bluetooth. On the left, you can see we've displayed the connectivity information of our Azure Service Bus, Event Hub, access policies, and security key that match our back-end Azure cloud environment. These parameters are being used by this application to send the event message data to Azure. On the right, you can see the current timestamp, humidity percentage, and Fahrenheit temperature being sent. The next part of the configuration to show is the Azure Event Hub. Here we are in the Azure portal. The Azure Event Hub configuration lives under the root Service Bus navigation tree. To utilize Azure Event Hubs, you must also have a Service Bus namespace created. Think of the Azure Event Hub as a child object to the Service Bus namespace. You'll also recall that we were required to use both the Service Bus namespace name and the Azure Event Hub name in our .NET application. Now I'll click on our Service Bus namespace and show you the Event Hub configuration by choosing Event Hubs on the top navigation bar. You'll see here that we only have one Event Hub, but your organization's Azure subscription could have many. The Event Hub has a dashboard page showing current activity, URL information, and finally, connection string information. On the Configure tab, we've got settings on message retention, partition count, which is related to the throughput and performance of this Event Hub, as well as information on the access policies and keys. These settings control the security and ability to send events to this Event Hub. That's all the configuration required on the Event Hub. The Windows.NET application I just showed you on the client PC has all the parameters required to be able to send event message data to this Event Hub. Now let's navigate to Stream Analytics and walk through the configuration of our Stream Analytics job. On the Stream Analytics job dashboard, you can see the job is currently running and processing inputs and outputs. You can also see that this job is currently using one streaming unit. Streaming units are units of compute and processing power that can automatically scale based upon demand. My demo has a very small amount of data being processed, so only one streaming unit is required. You'll see here on the Inputs tab that we are currently ingesting input from our Azure Event Hub that I just showed you. I only have one input, but you could have many. Here is the query of the Stream Analytics job. This query represents the real-time processing and filter we are performing on the input data, even from multiple inputs if you wish. You can see it's Transact SQL-like, and you can see here we are selecting specific data in humidity and temperature groups in a per second fashion with the tumbling window command. The possibilities here are immense and will of course be tailored to your specific scenario and requirements. Finally, let's take a look at the Stream Analytics job output. You can see here that we have a single output and that we are using Power BI. Within the Power BI settings, you will see here that we can configure the dataset and table names that will be created in Power BI for us. Before I show you Power BI, I want to remove a bit of the mystery and show you the raw data that is output from our Stream Analytics job. The output can be downloaded in the form of this JSON file. In order to get this output, I temporarily set my Stream Analytics job output to be of type blob storage and pointed it to my Azure storage account. If we look at my Azure storage account, you'll see here that I have one container called sensor blob. Inside of that container I've got 3 objects, and by pressing this download button you'll download this JSON file. Let's open that in Notepad. This JSON file will allow you to see the raw output coming out of your Azure Stream Analytics job. This is a great debug tool to allow you to test your query, your Azure Stream Analytics job configuration, your Azure Event Hub configuration, rather than trying to guess inside of your presentation solution, whether that be Power BI, like I'm going to show you shortly, or a custom web application, etc. Great tool for debugging and hopefully removes a little bit of the mystery for you. The final part of today's demo will be Power BI. This is the Power BI console. This is a web-based drag-and-drop canvas that allows self-service creation of reports and dashboards. As you've just seen, our sensor data has been ingested and processed by Azure Stream Analytics and is being sent here to Power BI for presentation. You'll see here that I've created a dashboard called Sensor, and I have 3 charts. 2 showing real-time temperature and humidity, and the center chart shows how many overall event messages I've received in this dataset from Azure Stream Analytics. Kind of a counter, if you will. I'd like to show you how easy it is to manipulate a report and dashboard in Power BI. Let's add another chart to our dashboard showing the max temperature over the life of the dataset. By editing the report, I get access to the Canvas tools and dataset fields on the right side of the screen. I can simply choose temp and what type of chart graphic I would like. In this case, I choose a meter, and that I want the max temperature in the value drop-down box. Power BI automatically builds this graphic chart on the fly, and we can then save our report and pin or save this to our dashboard for future reference. Back on the dashboard, you can see now the max temperature chart has been added. Finally, I'd like to show you how easy it is to drag and drop and customize our Power BI dashboard. And by blowing into my sensor, we can see our real-time dashboard in action. You can immediately see our charts registering the rise in temperature and humidity. This concludes our discussion and video demonstration. Thanks so much for watching. While this has been an extremely oversimplified example showing temperature and humidity, hopefully you've seen how easy it is to connect an IoT device to Azure Event Hubs, Azure Stream Analytics, and Power BI. The Azure tools and services available to your organization make IoT and data analysis scenarios easier and more affordable to develop and deploy than ever before. Please don't hesitate to reach out to myself or your Microsoft contact to discuss your specific vision and requirements. I also want to give a special thanks to Suresh, a program manager in our Azure product team. Suresh created the Windows.NET application and instructions for setting up this demo in the GitHub link displayed. Thanks again and have a great day.